Because if Bert took some, and this is the way you need to think about points in my class too. If Bert took some of these extra 100 points and donated them to his 61, he could take, say, 20 of those points, right? 20 of those points, give it to the 61 and make that an 81, and that's still an 80. So now you're just like the 82. And then he could take, say, 13 of these 94 points and donate it to this 68, and that becomes an 81, and so does that. And all of a sudden, his average is an 81. Well, his average is an 81, because that's essentially what the average does. It says, I no longer have 5 discrete scores. I think this is your guys' class came up with this analogy. There's a spittoon at the door, and you throw 100 things into it, and then you throw 68 things into it, and then 82 things into it, and then 94 things, and then 61 things. At the end of the day, you've got this, whatever that is, sums up to 400-ish things in a jar. Then you shake them all out and split them into 5 equal piles. Each one of those piles has 81 things in it. And it's 81 things for Ernie or for Bert. So anybody that votes that Ernie and Bert are the exact same student, I can't argue with that either, can I? Because they both average, they both center, they both typical, they both share the same amount. But that is not to say that there isn't some difference between them. Because obviously the first thing you guys say about Ernie is he's more consistent than Bert. So what we need a way to measure that. That's the kicker. So measures of center are great, but they need to be paired up with something in a way to measure variation. To measure variation. Here's a new word. A word for today, which we'll continue into Wednesday as well. So not just center. Center's great. Center's great. The problem with center is it ignores the extremes. And how extreme are the extremes? Well, we don't know. If all you see is this little chart right here with Ernie and Bert in it, you have no idea how the distributions actually are. We saw this also with my Math 95 exams in that bimodal graph from a couple of days ago. There was a spike in the F range and a spike in the B range. But on average, everybody got a 71. Well, if I say on average, class has got a 71, chances are your brain's going to envision a bell curve like this. You're not going to envision 2 spikes over here that cancel them up in the middle. But that's exactly what Bert did. And that's exactly what Ernie didn't do. So we need some way of indicating that difference. Some way of indicating that difference in consistency. So basically, I love your guys' words. I'm going to do it in this way if you don't mind. Inconsistency. So either consistency in the case of Ernie or inconsistency in the case of Bert, but some way of giving a quantification for that. Some way of giving a quantification for that using Bert and Ernie. This might help us answer this question. This might help us answer this question. I'm going to put this image back up from last time. No, crap, you can't see that. Now you can. Here. Here's the same look from last time. Oh, except I had the average, which is the one down here. There. There's Bert's and Ernie's on a number line. So essentially it's a dot plot. Kind of a lame dot plot because there's no mode. So therefore, Chester, back to your mode question, we don't really have a mode, or they're all the modes. Your choice. Whatever you want, or Shelby, your choice. Say whatever you want. I'm going to say there's no mode. Not enough data to really identify a mode yet. So, what do you think? How can we possibly measure the difference in these guys' test performances? We can't use centers, because centers don't show a difference. So what do you think? What's a way? What do you think, Tabitha?
The difference between their highest and lowest.
Love that, by the way. Tabitha just quoted. Oh, I should probably put the camera back on the graphic here. Tabitha just said, why don't we just look? It's not quite picking everybody up. Let me back this up a smidge. There we go. The difference in the high and the low. So, what would that be for Ernie? What would that be for Ernie? Ernie's the orange one. So I'm showing my age here. Any of you guys grew up on Sesame Street besides me?
And then you said word of the day earlier, and I was like, no, this is funny.
Was that Sesame Street word of the day? One of these words, not the other. Number of the day, word. Only a few of you grew up on Sesame Street. Electric Company? Of course. Oh, I'm showing my age here a little bit. Yeah, Ernie's the orange one. So, as knowing that Ernie's the orange one, his head kind of flipped off to the side. What's the difference between his high and his low, friends? 4. He goes from 79 to 83. So you can say, okay, Ernie's spread is 4. That variable, Tabitha, that Tabitha just quoted is called the range. And it's a good one. It's a good one. It ties to Beth's mid-range idea. Remember your mid-range, Beth, you asked about before? It's basically that. So their mid-range would be halfway between the 79 and the 83, which in this case is exactly 81. So the range of their data would be 4, or the range of Ernie's data would be 4. What would Bert's range be?
39.
39, which is essentially 10 times as big as Ernie's. Which I kind of like that. Bert's range is 10 times as big as Ernie's, which is a good indicator of how much more variable he is. How much more variable he is. Nobody truly uses the range in a regular basis. Now, I'm saying this on average. I'm sure there are industries that use the range quite a bit. But here's the reason why I don't particularly care for it too much. So you see Bert up there? Suppose Snuffleupagus was up there as well. Just pretend Snuffleupagus is up there as well. And he had test scores of 60, 98, 99, 100, and 99. So I'm going to say that again. I hope. 60, 98, 99, 100, and 99. And I hope those were the same 5 representations the first time. Okay, good. What would his range be? Wouldn't it essentially be the same as Bert's? It's essentially the same. He needs to be 40 versus 39. But would you say Snuffleupagus and Bert are the same? No, of course not, because Snuffleupagus had 4 test scores way up on the right side of that dot plot, where Bert only has 1 or maybe 2 if you get generous with them. So I'm not a huge fan of the range by itself, because the range by itself ignores the center. What I want to do is I want to not lose that plus sign that I put in here between measures of center and measures of variation. I want to talk about that plus sign in there. I want a measure that looks at them both together. So range is cool, except I'm not going to focus on it too much in this class if you don't mind, Tabitha. Just like with center, there are multiple measures of dispersion or variation, as it's called. I want to focus on one. So any other ideas? You guys can usually figure it out on your own if we experiment enough in here. I want to measure Ernie. I want to measure Ernie and his variation.
How far from his center?
How far from his center? Tabitha, you have nailed exactly the point of the variation that we're going to focus on. So, when we talk about variation, we're talking about variation from the center. Let me slide the camera over again. This is where the Lego car is going to come in handy, I think. I'm going to put one of you guys in charge of it. So, when we talk about variation in this class, I want you to think exactly of the wise words spoken by Tabitha. You're going to think of variation from the center. And in particular, a very specific center, the average. Variation from the average. That's the variation we're going to measure in this class. Why? Because it is the most commonly measured variation in an industry, in your research journals, in the stuff you guys are going to get to, in Gallup polls, in Quinnipiac polls, in mass media. That is the most typical. When they talk about variation, most of the time, I'm not going to give you a percentage because I don't know what the percentage is, but the lion's share, the majority of the time, you're talking about variation from a center point. Okay? So yes, that's key. So how are we going to measure it? Back to our data. Now we got to use that blue line, because the blue line's our average, right, friends? So how are we going to measure it? What do you think? I want to know how, pick one, Bert or Ernie. Your guys pick. Ernie it is. We're going to use Ernie. I thought I heard Ernie. I heard Bernie. Well, I heard Ernie. Sorry. We'll go with Ernie. Ernie has an average of 81, and he's got test scores of 79, 80, 81, 82, and 83. Let's talk about those test scores. Let's use Tabitha's definition. Variation from the average. Let's talk about his test score of 79. How does 79 vary from average? It's 2 points. Less or below. Over. I like this. Less, and I heard over. So I heard less, which gives me a direction, and over gives me a simple magnitude. So 2 points over could also be used to describe the 83, couldn't it? Now, what's cool about what both of you guys just said is, if we use just over and not less, Athena, we're talking about something called average deviation. Average deviation ignores if it's to the left or to the right, and just looks at distances. So it's kind of like when you leave your house in your car in the morning, go to school, and then go back home. It's what your odometer would register. So if it's 6 miles, you do a 12-mile round trip. If you look at it in Tabitha's specter of left, not just over, you actually go 0 miles because you end up back where you started. And that's important. That's an important distinction. It's position versus distance. The bad news about the way you described it, over versus direction, is nobody actually uses it. But there's a reason why. There's a good mathematical reason why I think it. It's a very logical measure. I want to come back to it because it is the most purely logical, and for years I wouldn't let it go. It's called average deviation. What you pretty much do is you go, okay, that's 2 over, 1 over, 0 over, 1 over, 2 over. So I got 2 differences of 2, 2 differences of 1. If I add all those together, that's 6 total differences. Divide by 5 is 1.2. So on average, he's 1.2 points off his average. That's the average deviation. No one uses it. It's so simple. But the problem is, how much math do you want to hear right now? None. It's break time. Let's come back to that. 0 math rule. Turn the damn camera off. Let me get some water. Yes.